This is Ashkur Rahman Imran, and I'm with you Microsoft SQL Server with Azure Data Studio. So in this tutorial we will show you table creation with foreign key and with constraint. So when we are using database, we need to create table for keeping our data row by row. So I have collected this information from Microsoft Docs. Is a special data type that can be used to store a result set for processing at a later time. Table is primarily used for temporary storage of a set of rows returned as the result set of a table valued function. Function and variables can be declared to be the type table. Table variable can be used in function store procedure and batches to declare the variable of type table. So this is an object which stored in the database. So when we create a table, it create a object inside of our database, and we can keep our data row by row in a tabular format in our database. So simple table SQL command. So this command create table, table name, column name, and data type. Such as like example, create table person, integer, last name, worker 255 length, first name, worker 255 length, etc. And some other commands. Drop table, table name, and truncate table, table name, alter table, table name, add column, data type. So this is altering a table and adding a column. Alter table, table name, drop column. So again this is altering a table and dropping a column. And alter table, table name, alter column. So this is altering a column with different way. So now I'll show you the way how to use these things. So first we need to create table. So already in our last work we prepared database with Ashik. So next we are doing a query here. Okay, so SQL create table. This is the shortcut already I shown you in the first tutorial, but I'm using it again. So we don't need these things because we are creating a table. Already we know that we don't have any table with this name. Okay, so we are creating a table. The table name is person. So person has ID, type integer, and this is a constraint that we are keeping here. Okay, and we're giving here identity 1 comma 1, and again we are adding a column person first name, person last name with the length of 50, and this column shouldn't be null when we are inserting any value inside of these columns. And we are adding another row, so address, and we're changing the length. This should be 100, and we have to insert all the information when we're inserting any data here. So I'm running this command, and if we check the tables, the person table is done. So now we're inserting data here. So table name is person, and columns are already I have shown you some shortcut SQL select list list columns from table name person. So if we run this command, we'll get the row list with data type. So we don't need only these three columns. So I'm putting these columns here and I'm giving comma. So now we need to give some value here. So the first name, is Bangladesh. So this is enough. So now we are inserting this information in our database. So what is happening when we are executing this query? Oh, executed successfully. So if we are selecting SQL select from table person and there is no where condition here, so what we get? Oh, the data inserted successfully. So if we are inserting another data, Rahim, Mia, so this is also with Dhaka, Bangladesh. So what we get if we run this command again? Oh, two data inserted successfully. So, and in the other side, we can drop table with this command. And there is a command truncate table name and what it does actually. So what we have in this table, ID and first name, last name, address. So if we are deleting so if we run this command, oh, the table is empty, so it's deleted all the data from this table. So if we insert the same data here, then if we run it again, oh, our primary key is 3. So if we delete all the information from the table, but our primary key number is already from the last one with one increment, right? But what we'll get if we truncate the table? Okay, oh, truncated successfully. So no data again, and if we run this command and oh, it started from 1 again. So when we are doing this kind of things, so what actually done from delete and truncate? Delete actually clean all the rows from the table, but it keep all the indexes already available in this table. But if we truncate any table, then it clear all the indexes, such as like our last index was 2 according to identity primary key, but when we delete it, the next row was 3. But when we truncated, again we insert, then primary key started from 1. So these are the things. So, and these are the procedure for altering table. So we are adding another column, SQL alter add column. So table name is person. Okay, we are adding age. Table name is person and data type is integer and it allowed null. So we are altering this table. Oh, table alter successfully. So if we run the select command again, SQL select person, and there is no where condition, again we'll check all the information. Oh, the age is null, so we allowed null here. If we enter another information such as like KJ Rahman, and we want to insert the age information together, 30. If we run this command, oh, it should be age, and the value should be here, 30. Oh, so the new row added with the age, the table altered successfully. So these are some other commands: alt table add column, drop column, and alt column. So if we write the query with this way, then the query will execute successfully and we can alter the table columns. So this is the simple way to create table in database. And when we are creating table, we are giving some information such as like primary key, not null, and unique, foreign key, check, default, index. So already we have used primary key as identity. So in ID column we already used primary key, a combination of a not null and uniquely identities each row in a table. So primary key, it should be not null and it should be unique. So each row will contain a unique primary key as a constraint. So in the another side, unique is also unique, such as like primary key. Ensure that all the values in a column are different. So maybe we can have 10 rows, but all the values should be unique. And not null already we used there. So ensure that a column cannot have a null value. So if we use this constraint, then we cannot enter any null value or empty value on that column. And these are the things: foreign key uniquely identifies a row or record in another table. So in database, sometime or many time we need child table and child information, such as like a student and his subjects. So student is a parent table, so we can keep all the information such as like his role and his class, this information in student table. But in subject, one student can have many subject, so we can keep a foreign key of student ID in subject table, that we can find that this student has these subjects. So for that reason we use this foreign key constraint and check, ensure that all value in a column satisfy a specific condition. So this is the most important thing. Sometimes we check these things from our coding side, but we can define these things properly in our SQL, such as like age cannot be less than 18. So if someone enter age 17, then it will check before inserting. So, and the default sets a default value for a column when no value is specified. So with this constraint, if we are not specifying anything, then default value will be automatically set in that column. And index used to create and retrieve data from the database very quickly. So when we need to retrieve any data very quickly, such as like with where condition, then we need to use this index. Okay, right now we can create table with child information. So as we said that SQL create table student, So as we can keep this ID, and we can use identity again, and name class. So the student table is done. So now we'll create the subject table. So ID, subject name, subject code, and student ID. And how can we keep this foreign key? So such as like constraint, and we can declare a constraint fk inv product id, and with this kind of condition, foreign key product id reference product id. So student id integer, not null. So we have to create foreign key here. So what is written here? Foreign key with this own table column, this product id. Okay, foreign key with student id, then reference products. So we'll reference student. ID. So the reference is done, but we haven't declared any constant, so the default constant will be declared automatically. And on delete cascade, so when to use these things and when not. So when we are deleting any student information, then it will delete all the child information automatically. So when the student is deleted, then we don't need this subject information. So the on delete cascade is on. So the student and subject table is done, but sometime we need when the student is registered. So created on date time default get date. So this is a column that will keep when the student information is created. So this type is date time and default value is get date. So this is SQL default function. With this function what we get, so if we run this function, so we are getting current date time with this function. So this both table is done, so we're running this command. So what is the status? So student and subject table is done. So if we check the columns created on keys, this is the primary key of the student table, and what are the constant? This is the constant and index. So unique class start, and the student table is done. If we check the subject columns, So the student ID is working as a foreign key. So this is another constraint. So if we check the constraint, no, because we haven't declared any constraint here. So there is a primary key and a foreign key. And if we check the index, this primary key index with clustered, and the primary key working as a statistics index. So now we want to insert some information in subject table. So again we need the columns, SQL list columns subject. So ID, subject name, subject code, student ID. So okay, we want to insert some information here. So subject name, student ID. So the subject name is Bangla Math 201. Subject code is 201 and student ID is null. So if we want to insert the information with this way, what is happening? Let's try. Cannot insert null value in student ID column in the subject table. So okay, we are giving a value here 1. So again we can try to insert. Cannot insert null value in column ID. So already we have prepared the ID column with this way. Okay, we can alter the ID column. SQL alter subject ID subject table DBO and the data type is not null. So we are altering this column. Alter column ID. Okay, we can check the syntax. So alter table, table name, alter column, column name, data type. So alter table, okay, the subject table and alter column ID integer. So incorrect syntax near keyword identity. Okay, we are adding this table again. And subject and ID primary key not now, and identity, and subject name, then subject code, and integer not null, and foreign key with this student ID references student ID. So we are preparing this table again. So now our SQL query is done. So if we want to insert again, so insert statement conflicted with the foreign key constraint, such as like there is no student with this ID. So now SQL insert rows, table name, stud and student, and how many columns we have in this table. So ID and name class John, and class 12. So when to insert this information here, oh, one row is affected, so select all from student. So these are the created information already by default insert here, as we use the default constraint. So the student table is done and the ID is 1. So if we want to insert any information here, so with for student 1, oh, the data inserted successfully, and ID is 2 and student ID is 1. Okay, we want to give him English. So oh, again inserted successfully. So if we check, oh, the student 1 has two subject, math and English. Both subject code is 201, but the name is different. Okay, so if we want to delete this student, okay, we're deleting. Conflicted reference key foreign key student has conflict, so it has already two information. So if we want to delete, then we must clear this child information before deleting. So if we delete, subject where ID equal to 1, oh, if now we try, both is deleted successfully. Oh, both is working fine. So now we can prepare table with this constraint. So now we can prepare this constraint with these things, and constraint with cascade delete. So on delete cascade. So if that ID is deleted, then it will delete automatically with cascade. So SQL check constraint. So create table person ID. So the what will perform by check constraint. The check constraint is used to limit the value range that can be placed in a column. If you define a check constraint on a single column, it allows only certain values for this column. If you define a check constraint on a table, it can limit the values in the certain columns based on the values in the other columns in the row. So, how to use this? Constraint check person check age should be greater than 18. Okay, so we need more extra column. SQL add column, table name student, and column name is age, table name is student. So the type is integer and it will allow null. Okay, that is very good. But now we need to create the constraint for this. So what is the procedure? Constraint and the constraint name. Okay, check age. So after that, the condition inside of this check. So age should be greater than 18. So if we are altering or altered successfully, so now we want to add a student with the age of 12. Okay, so the student column is added successfully, the age. And if you check the keys and if you check the constraint, so it has another constraint, check age. Okay, we want to add a student with name Kim, and insert is statement conflicted with check constraint check age. The conflict occurs in the database, so we can't insert. So if we provide the age with 19, inserted successfully. So select all from student. So what we get? The student inserted successfully with this age. So in this way, this check constant work. And after that, the index. The create index statement is used to create indexes in the table. Indexes are used to retrieve data from the database very fast. The user cannot see the indexes. These are just used to speed up searches queries. So we can create index with a name on a table with columns. So even we can create a unique index in table. So now we want to create an index. SQL add column. So column name is phone number, and the table name is student, and type is worker 50, and it allowed now. So now we need an index on this column. So what is the procedure and syntax? Create index name on table name. So we are adding this column. Column ordered successfully. Now we want to create index. So SQL create index. So what is the table name? Student, and index name is phone. Oh, sorry. SQL create index. So the table name is student. DPO is okay. Database name. Okay. What will be the index name? IX phone number, and column name is phone number. So this is the index name, so we don't need this. Already we have selected the database and schema, which is default TBO, and we just need to select this column. So and table, we are creating this index. Index statement failed because key list is missing. Created index. So created index statement fail is specifying key index list is missing when creating an index. So if we refresh this table column, so we have phone number. So what is the procedure? Create index. So and index name on table student and column name. So now if we run incorrect syntax name ASC. So the command executed successfully. If we check the index phone number is non-unique and non-clustered index, but it will perform for searching when we are searching any student with the phone number. So in this way we use the index constraint, and identity already used in primary key. So auto increment allows a unique number to be generated automatically when new record is inserted into table. Often this is the primary key field that we would like to be create automatically every time a new record is inserted. So when we need this thing, so in the identity column we use in primary key. So such as like we need auto incremented, such as like 1 2 3 4. So in that time we use this identity, and in this way we can create table with foreign key with several constraint. So thank you very much, and stay connected and get everything, and stay connected for getting latest update. Thank you.